Example that's typically presented when you are looking at conditional probabilities. Consider a clinical test. Let's say there's a test that identifies a carrier of a disease. You hand in a blood sample, and as a result, the test tells you are positive or negative, carrying a disease or not. So clinical test. Is this the right screen? Yes. Clinical test. Let's say overall there's a chance of 1 in 1,000 that a random person from the population is carrying the disease. Yeah. So the probability is 1 in 1,000. Now, this test is not 100% fail-proof. Let's say there is a 1% chance that it returns a negative result, even though you are positive. Yeah. Let's say we call this event A. So somebody is carrying a disease, and let's say the event test result positive. We call this B. Yeah. So in our formalism, the probability that even though somebody is positive, the test returns negative, is the probability B given A naught. A naught means no, that's wrong. B naught A. Yeah. A means somebody is positive, and B naught means the test result is negative. That this is 1%. And there's also the probability that the test returns a positive result, even though you are perfectly healthy. Yeah. So that means a P B given A naught is 0.05. Yeah. Okay. So we can also then create here from this. There follows that the test is positive if somebody is infected, that this is 0.99. Okay. And now we can ask a couple of questions. Let's say somebody just had a positive test result. Yeah, you went to the hospital and this test was carried out and you got the result, it's positive. Now what's the probability that you are actually a carrier of this disease? We can also let's start with this tree diagram thing again. So somebody is either having a disease or not. So that was 1 in 1,000, and that's of course then the complementary case. And then we have here the two cases, positive and negative result. Okay, so we know this is 0.01. That's what we have written here. We also know that this then is 0.99. And we know that this is 0.05, and then this is, of course, this result. Okay, now, what was it? I said the test result is positive, so that means we are either here or here. And we would like to figure out, is it A or A not? So we are asking for the probability we are carrying disease given our test was positive. And we can write this down using the Bayes theorem again. PA, and then divide through the two cases. Okay. Let's briefly identify the terms. This here is this. Okay? PA, of course, is here. This one is this probability, and PA complement is this. And if we now put in numbers, let's briefly do this. So that's 0.PB given. A is 99% times 1%, and that's times 0.999. Okay, and that's 0.094. So even though you had a positive test result, the actual chance that you are carrying the disease is only about 2%. Yeah? Because of the relative high probability of the tests to return a false result. We could also ask the opposite question, namely, you had this test done and the result was negative. There's still a chance that you are carrying. And what's the probability? So we write this down similarly. So you are carrying the disease, that's the event A, but your test result was negative. What's the chance? And that's then PB not given A, probability A, and here we have PB not A, PA plus PB not and A not, PA not. Again, we can fill in here the numbers. So these are small numbers. Plus, what is it here? 0.95 times 0.999. And that's 10 to the minus 5. Yeah? So that's a very small number, so it's pretty safe to assume that you are not carrying the disease. But there's also no immediate reason to freak out because you had a positive test result. Yeah? Under these conditions.